Dear students, today we are going to start linear programming of class 12. In linear programming, we have to study about the constraints, about the objective function, and at first we have to discuss what is linear programming. So, let's discuss at first the definition of linear programming. I'm going to write the definition of linear programming. The determination of the maximum or minimum allocable value or optimal value of a certain function under the certain given condition. Is linear programming. Students, the determination of maximum or minimum. The determination of maximum or minimum value or allocable value or optimal value of a certain function. There is a certain function under this certain given condition. There should be a given condition is called a linear programming. Or we can write, also we can define by other way, a mathematical procedure for determining the best outcomes. Determining the best outcomes such as maximum profit and lowest cost of an objective function in a region satisfying set of constraints is called a linear programming. Linear programming, or we can say LP. Students, I think you are clear in the second definition also. A mathematical procedure for determining the best outcomes such as maximum profit. We have to gain maximum profit or lowest cost of an objective function. There would be an objective function, and in a region satisfying set of constraints is called linear programming. Now we are going to discuss some of the fundamental terms which is used in linear programming. Some of the following fundamental terms are to be understood in the linear programming. The first one is decision variable. Decision variable. And then second one is objective function. Objective function. And the third one is constraints. Now we have to know what is decision variables, objective function, and constraints. Now at first we have to discuss about the decision variable. Those non-negative variable, those non-negative independent variable, which are to be used in the solution of linear programming problem are the decision variable. Students, I think you know by the terms also. Here is non-negative independent variable which are to be used in the solution of linear programming problem are decision variable. For example, main, materials, machine, etc. are the example of etc. are the examples of decision variable. Now we are going to write the definition or write the meaning of objective function. Number 2 is objective function. It is the linear function that is to be optimized. That is to be optimized. The goal of objective function the goal of objective function is to maximize or minimize the function. Dear students, objective function is a linear function that is to be optimized. The goal of objective function is to maximize or minimize the function. For example, suppose 2x plus y, 5x plus 7y, etc. are the examples of objective function. Now, number 3 is constraints. In case of solving linear programming problem, the decision variable have to satisfy the certain condition or restriction certain conditions or restrictions. The condition to be satisfied by the decision variable variables are known as the constraints. For example, food item costing Rs Rs 50 per unit and clothes costing at 400 per piece. If she has 5,000, or we can write Rs 5,000 only, Rs 5,000 only to buy X and Y. X and Y are the number of food item and pieces of cloth respectively. Then अब हेर्नुस् है त according to this example, here is a housewife wants to buy food items costing Rs 50 per unit. Here is 50 per unit of food item, and then Rs 400 per piece of cloth costing. So we have to write 50x, because here x we can write this type of x, 50x plus 400y, and she has Rs 5000 only. So this is less or equals to Rs this 5000, and we can write x y is greater or equals to greater than 0. So this is the condition to solve this question in linear programming. Now we are going to discuss some problem related to linear programming. We discuss up to here about the decision variable, similarly about the objective function, and about the constraints, and we know what is linear programming also. Let us discuss very simple example of linear programming at first, then we will solve complicated question of linear programming. Students, now we are going to start question number 1 of linear programming, and this question number 1 is little easy question, and then we will solve question number 2 and 3 being more complicated. Okay, the first question is question number 1. Draw the graph of the following inequalities. And the question is x plus y is less or equals to 6 and x minus y is greater or equals to minus 2. So how to solve this question? Solution. The corresponding equation of the given linear programming of the given inequality in given inequalities are, we have to write this x plus y is less or equals to 6. This is an inequality. Now we have to write this in equation. So we can write x plus y is equals to 6. Similarly, this x minus y is greater or equals to minus 2. Also we can write in equation form x minus y is equals to minus 2. Which is in the form, this is equation 1 we can write, and this is equation 2. From equation 1, from equation 1 is this one, so we have to start from equation 1 at first. Equation 1, x plus y is equals to 6. Now we have to draw one table, and where we can write x and y. So we can put x is equal to, suppose x is equal to 0. If x is 0, then y is 6. हामीले यसमा चाहिँ x लाई सबभन्दा पहिले x अथवा y लाई 0 राखेर ट्राई गर्छौं, किनकि 0 र 6 हाम्रो कोअर्डिनेट आयो भने हामीलाई ग्राफमा प्लट गर्नको लागि इजी हुन्छ. So we put it here, x is equal to 0, and then when x is equal to 0, 0 plus y is equal to 6. So y is equal to also 6. And when y is equal to 0, we can write 0 here. When y is 0, then x plus 0 is equals to 6. So x is also 6. So we have 2 points, 0, 6 and 6, 0. Let's plot these 2 points in a graph. Here we can write when x is equal to 0, y is equals to 6, and when y is equals to 0, x is equals to 6. So the boundary line I, equation 1, passes through the point 0, 6, 0, 6 and 6, 0. First one is 0, 6, second one is 6, 0. This equation 1 passes through these 2 points. Now we are going to plot these 2 points on a graph paper. Students, we have here, this one is origin O, 1, 2, 3, 4, 5, 6. Similarly, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, 3, 4, 5, 6. This is y-axis, y, and then this one is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. This is y dash. This one is x, and then this one is x dash. Here we have to write the scale. Here is 10, 20, 30 small division scale. 30 small division is equal to 1 unit in x and y axis or both axes. X-axis and y-axis. 30 small division is equal to 1 unit. Students, you can take only 10 small division is equal to 1 unit in your small graph paper. Now we have to plot these 2 points 0, 6 and 6, 0. 0, 6. 0, 6 is this one, 0, 6 is this one, and then 6, 0 is this one. So let us join these 2 points, and the name of this line is x plus y is equals to 6. This is equation 1. X plus y is equal to 6 is the name of this line. Now we have to take the testing point. Taking testing point. Taking testing point. Testing point 0, 0. If the line doesn't passes from 0, 0, we can take testing point 0, 0. So when x is equal to 0, then we have the equation x plus y is equals to, x means 0 plus y means also 0, because putting the value of x 0 and y also 0. So 0 plus 0 is also 0. But we have in the question x plus y is less or equals to 6. So we have to write it here, which is less or equals to 6. So 0 is smaller than 6, which is true. So this one is true. Therefore, the plane region determining determine by x plus y less or equals to 6 is the closed half plane containing the origin यो लाइनले हेर्नुस् त अब हामीले ओरिजिन तिरको पार्टलाई चाहिँ रिप्रेजेन्ट गर्छ यो हाम्रो गिवन इनइक्वालिटीजले यो लाइन भन्दा ओरिजिन तिरको पार्टलाई रिप्रेजेन्ट गर्छ भनेर हामीले देखायौं यसलाई चाहिँ हामी अब यसरी हामीले चाहिँ यसलाई स्याडो गर्नुपर्ने हुन्छ हामी एकछिन अर्को लाइन यसको पनि हामी प्लट गर्छौं अनि मात्रै स्याडो गर्दै छौं Students, now we are going to do from equation, not first, from equation second, this equation, and we have x minus y is equals to minus 2. So let us draw one table, and here we can write x and then here is y. So if we'll put the value of x0, then y is here 0 minus y is equals to minus 2, and then minus y is equal to minus 2, so minus minus cancel, y is equal to 2, we can write like this one. So again, when y is equal to 0, here when x is equal to 0, and then when y is equal to 0, then x minus 0 is equals to minus 2, therefore x is equal to what? Minus 2. So if we'll put it here y is 0, then x is minus 2. So let us plot this 0, 2 and minus 2, 0 in the same graph paper. Therefore, we can write the boundary line II passes through 0, 2 and minus 2, 0. So let us plot this 0, 2 and minus 2, 0 on the same graph paper. 0, 2 we have here 0 and then 2. 0, 2 is this one, this point, and then again minus 2, 0 is minus 2, 0 is this point. So let us join these 2 points again. This is the line, and the name of this line is x minus y. X minus y is equals to minus 2. Now we have to test again by taking a testing point. यो टेस्टिङ पोइन्ट हामी किन लिँदै छौं भने हाम्रो यो इनइक्वालिटी छ क्वेशनले दिएको यो इनइक्वालिटीले चाहिँ यो लाइन भन्दा कतापट्टिको एरियालाई चाहिँ शो गर्छ इन व्हिच पार्ट इट शोज इट रिप्रेजेन्ट्स एरिया कुन चाहिँ एरियालाई यसले रिप्रेजेन्ट गर्छ भन्ने थाहा पाउनको लागि हामी टेस्टिङ पोइन्ट लिँदै छौं टेकिङ टेस्टिङ पोइन्ट testing point 0, 0. So testing point 0, 0 we have our question is x minus y. So x minus y is equals to x is 0 minus y is also 0. So 0 minus 0 is also 0. But our question is greater or equals to minus 2. Now we have to compare 0 is greater than minus 2 or smaller than minus 2. Yes, I think you know 0 is greater than minus 2. 0 minus 2 भन्दा ठूलो छ त्यसकारणले this meaning is true, which is true. त्यसकारणले यो ट्रू हो भने therefore हामीले यसभन्दा अगाडि लेखेको जस्तै गरेर therefore the plane region determined by x minus y, we have here x minus y is greater or equals to minus 2 is the closed half plane containing the origin. So in this way we can plot it here. This arrow represents the solution of this x minus y is greater or equals to 2. So we can write it here, x minus y is greater or equals to minus 2 is the solution set of our this given equalities. And then this one is also, we have to write here, x plus y is less or equals to 6. Students, and now where is the solution set? If we shadow it here like this one, if we shadow it like this represents x plus y less or equals to 6. And similarly we have to shadow up this part also. So x minus y is greater or equals to minus 2, it represents this one. Students, look very carefully. Where is the double shadow part, or where is the double intersect form? And here is, this part is the solution set of this question. So this is the solution. This is the solution. So we have to write, therefore the cross area of x plus y less or equals to 6 and x minus y greater or equals to minus 2 is the solution set. In this way we solve this question. Students, sometimes this question asks only in 2 marks or short question. This is the short question. Now we are going to solve another one long question. Students, now we have another one question. Our question number 2 is, find the corner points or vertices of the following Carpenter's problem subject to 2x plus y is less or equals to 40, that's labor constraint, and then x plus 2y is less or equals to 50, that is material constraints, and then x y greater or equals to 0, that is non-negative constraints. Now we are going to solve this question. Okay, be clear. Solution. Suppose x and y denote the decision variable. Now the corresponding equations of the given inequalities are, students, here 2x plus y is less or equals to 40. So we have to write the equation 2x plus y is equals to 40. Similarly, this is 2x plus 2y is less or equals to 50. So this equation is x plus 2y is equals to 50. We can suppose this is equation 1 and this is equation 2. Similarly, we have here x is greater or equals to 0, that one is x is equal to 0, and next one is y is equals to 0. We can say this one is equation 3 and then this one is equation 4. Now from equation 1, this 2x plus y is equals to 40 is the equation 1. 2x plus y is equals to 40. So when x is equal to, if we'll put 0, then what is the value of y? Look here, when x is equal to 0, then 2 times 0 plus y is equals to 40, which gives y is equal to 2 times 0 is 0, so y is equal to 40. So if we'll make one table like this one, here x and then here y, So when x is equal to 0, then y is equal to 40. So when y is equal to 0, then we can look here. When y is equal to 0, then 2 times this is 2x plus y means 0 is equals to 40. Therefore, x is equal to 2x is equal to 40 and x is equal to 20. So we have to write it here 20. So we have the 2 points 0, 40 and 20, 0. Therefore, the boundary line, boundary line 1 passes through 0, 0, 40 and 20 and 0. Let's plot these 2 points in a graph. This is a here graph. So we have to plot it up to 40 here. So let us suppose this one is 5. So 10, 15, 20, 25, 30, 35, 40. Here also 5, 10, 15, 20, 25, 30, 35 and then 40. Let us say this one is y and this one is x. So this one is x dash and this one is y dash. So here is minus 5, minus 10, minus 15, minus 20 like this, 25, minus 30 like this one. Here is minus 5, minus 10, minus 15, minus 20, minus 25, minus 30 like this. So let us plot this point 0, 40. This one is 0 and then 0, 40 is 0 times 40 is this point. And then 20 and 0. 20 and 0 is, let's look, x-axis 20 and then y-axis 0. So let's join these 2 points. Let us take a testing point. हामीले यो प्लट गरिसकेपछि टेस्टिङ पोइन्ट लिन जरुरी हुन्छ. यो हाम्रो ग्राफ चाहिँ के हो भन्दा 2x, हेर्नुस् है, यसको नेम के हो भन्दा 2x plus y is equals to 40. यो लाइनको नेम चाहिँ इक्वेसन हो, त्यसकारणले इक्वेसनको फर्ममा हामीले यो लेख्यौं. अब हामी यसलाई चाहिँ यसले यता रिप्रेजेन्ट गर्छ कि यो अदर साइडमा रिप्रेजेन्ट गर्छ हामीले फाइन्ड आउट गर्नुपर्ने छ. त्यसको लागि हामी टेकिङ टेस्टिङ पोइन्ट भन्छौं. टेकिङ टेस्टिङ पोइन्ट 0, 0, 0, 0 बाट यदि त्यो लाइन पास भएन भने हामीले टेस्टिङ पोइन्ट 0, 0 लिन सक्छौं. बिकज if we'll take testing point 0, 0, it is more easier than other number. So we have here 2x plus y is equals to 2 times x is 0 and then y is also 0. So here 0 plus 0 is equal to again 0. So here is less or equals to 40. 0 is less or equals to 40. यो हामीले यहाँबाट जस्ताको तस्तै यसलाई लगेर यहाँ राखेका छौं. either this one is true or not. हेर्नुस् त 40 भन्दा 0 यसले के देखाएको छ भन्दा 0 चाहिँ स्मलर छ भनेर देखाएको छ, which is true. 0 स्मलर पनि हो, is true. यदि यो ट्रू हो भने हामीले चाहिँ यो लाइनले के रिप्रेजेन्ट गर्छ भन्दा यो लाइनले यो ओरिजिन तिर नै रिप्रेजेन्ट गर्छ. त्यसकारणले we can give like this arrow and then यो लाइन भन्दा यतापट्टिको एरियालाई केले रिप्रेजेन्ट गर्छ त हाम्रो क्वेशन 2x plus y less or equals to 40 ले रिप्रेजेन्ट गर्छ. We have to write the solution set 2x plus y less or equals to 40 represent the closed half plane containing origin. यो ओरिजिन सहितको, हेर्नुस् त, ओरिजिन तिरको यो लाइन सहितको ओरिजिन तिरको पार्टलाई यसले रिप्रेजेन्ट गर्छ भनेर हामीले यसरी देखायौं यो पार्टलाई चाहिँ. अब हामीले फेरि हामीसँग अर्को इक्वेसन छ, that one is यो हेर्नुस् त x + 2y इज इक्वल्स टु 50 त्यसकारणले फ्रम इक्वेसन 1 भनेको ठाउँमा अब हामी के भन्दै छौं फ्रम इक्वेसन 2 भन्दै छौं अब हेरौं है त we have the equation 2 is x plus 2y is equal to 50 छ let's draw one table here where x and y are the two variables. If we'll put x 0 then हामीले सकेसम्म x को भ्यालु चाहिँ 0 राख्यौं भने सजिलो हुन्छ x 0 भयो भने हेर्नुस् त y कति हुन्छ 2y = 50 y = 25 आउँछ त्यस्तै फेरि if y 0 then 2 times 0 y is 0 2 times 0 is 0 so x is equal to 50 50 राख्नलाई हामीलाई अलि गाह्रो पर्न सक्छ त्यसकारणले हामीले यसमा चाहिँ यो 50 सम्म हामीले प्लट गर्नुपर्ने हुन्छ हाम्रो ग्राफमा 50 नभएको कारणले गर्दाखेरि हामीलाई गाह्रो पर्न सक्छ त्यस्तो अवस्थामा हामी यो 0 नगर्न सक्छौं यसरी यदि x = हामीले सपोज 20 लियौं भने हेरौं है त if x = 20 then 2y = 50 minus 20 50 minus 20 is 30 30 by 2 is 15 so when x = 0 कसरी भन्नु होला तपाईहरु हेर्नुस् है त when x = 20 भयो भने 2y = 50 हुन्छ so 2y = 50 minus 20 हुन्छ y = 50 minus 20 भनेको 30 upon 2 भयो and then this means 15 आयो यसरी चाहिँ 20 र 15 आउँछ अब यसलाई चाहिँ हामी यो 0 25 र 20 15 लाई चाहिँ हामी प्लट गर्दै छौं हेर्नुस् है त द बाउन्ड्री लाइन हाम्रो यो सेकेन्ड लाइन हो two line passes through के भयो त भन्दा 0 25 and 20 15 यसरी यो बाउन्ड्री लाइन हाम्रो सेकेन्ड इक्वेसन को यो बाउन्ड्री लाइन चाहिँ यसबाट पास हुन्छ यो दुईटा पोइन्टबाट भन्यौ 0 25 कहाँ पर्छ होला त 0 25 भनेको हाम्रो 0 25 यो पोइन्ट पर्न आयो 0 25 त्यस्तै 20 and then 15 भनेको हेर्नुस् है त 20 and त्यसपछि 15 हाम्रो यहाँ पर्न आउँछ 20 र 15 अब यसलाई हामीले चाहिँ जोइन गर्दै छौं अब यसमा हामीले चाहिँ यो लाइनको नेम चाहिँ के हो भन्दा x + 2y = 50 लाइनको नेम हो यो लाइन अथवा हाम्रो यो क्वेशनले कता रिप्रेजेन्ट गर्छ यो क्वेशन x + 2y = 50 ले यो लाइन भन्दा माथिको पार्टलाई रिप्रेजेन्ट गर्छ अथवा तलको पार्टलाई रिप्रेजेन्ट गर्छ हामी त्यो अब हेर्ने छौं हेर्नुस् है त टेस्टिङ पोइन्ट 0 0 ल्याउँ भने हाम्रो क्वेशन के छ भन्दा x + 2y = 0 + 2 times 0 भयो so 0 + 0 is 0 + 0 is also 0 तर हाम्रो यहाँ के छ भन्दा हेर्नुस् त lesser equals to 50 छ अब 50 भन्दा 0 स्मल छ कि ग्रेटर छ सो 0 चाहिँ 50 भन्दा स्मलर छ त्यसकारणले which is true यदि ट्रू भयो भने यो कतापटि चाहिँ पर्छ भन्दा यो ओरिजिन तिर नै स्याडो पर्छ यो 0 0 तिर नै स्याडो पर्छ त्यसकारणले अब यसको नेम के भयो त हेर्नुस् त x + 2y > 50 भयो यसले यसरी यो एरियालाई रिप्रेजेन्ट गर्यो अब हामी देयरफोर के लेख्दै छौं त हेर्नुस् त देयरफोर द सोलुसन सेट हाम्रो के हो त यो अहिलेको यो x + 2y > 50 जुन हाम्रो क्वेशन हेर्नुस् त यो फर्स्ट पार्ट हामीले सिधाइसक्यौं अब सेकेन्ड पार्ट हामी राखेका छौं 50 रिप्रेजेन्ट्स द क्लोज हाफ प्लेन कन्टेनिङ ओरिजिन भनेर हामीले यो राख्यौं स्टुडेन्ट्स नाउ we have to do this one. These two already we finished. And now x is greater or equals to 0 and y is greater or equals to 0. Or हाम्रो equation third भनेको x is equal to 0. Equation 4 means y is equal to 0 छ. So which line represents x is equal to 0? So x is equal to 0 is y axis. यो y axis मा x is equal to कति हुन्छ 0 हुन्छ. त्यसकारणले यो लाइन हो x is equal to 0 को हामीले यसलाई डाइरेक्ट गर्न सक्छौं हेर्नुस् त x is greater or equals to 0 छ x is greater or equals to 0 छ x 0 भन्दा ग्रेटर भयो भने यो लाइनले यसरी रिप्रेजेन्ट गर्छ त्यस्तै फेरि y अब यसको पार्ट पनि सिद्धियो त्यस्तै इक्वेसन 4 y is equal to 0 छ y is equal to 0 means यो x एक्सिस भनेको y is equal to 0 को लाइन हो। त्यसकारणले यो हेर्नुस् त हामीले यसरी दियौं भने यो y is greater or equals to 0 हुन आउँछ। यो x एक्सिसमा y 0 हुने भएकोले र यो लाइन भन्दा माथिको पार्ट चाहिँ यो y 0 भन्दा ठूलो पार्ट हो। त्यसकारण यसलाई पनि हामी यसरी सो गर्न सक्छौं, which represents y greater or equals to 0. Students, now we finish x is greater or equals to 0, y is also greater or equals to 0. अब यो सबै चीजले चाहिँ रिप्रेजेन्ट गरेको एरिया, सबैले रिप्रेजेन्ट गरेको एरिया कुन हो त यो ग्राफमा? Can we show this one? अब हामीले हेर्नुस् है त, यहाँ हामीले बिस्तारै स्याडो गर्दै छौं। यसले रिप्रेजेन्ट गरेको एरिया यो हो। कसरी तपाईहरुलाई यसमा कन्फ्युज हुन सक्छ? हेर्नुस् है त, एकछिन तपाईहरु विचार गर्नुस्। यो हाम्रो हेर्नुस् त, यो लाइन यसरी छ, यो लाइन भन्दा यताको पार्ट भनेको छ, त्यसकारणले यो लाइन भन्दा यता पर्यो। त्यस्तै यो लाइन भन्दा माथिको पार्ट भनेको छ, त्यसकारणले यो लाइन भन्दा माथिको पार्ट भन्नाले यो भाग पर्यो। अब यो लाइनले हेर्नुस् त रिप्रेजेन्ट यसरी यो यस्तो भनेको छ, त्यसकारणले यो लाइन भन्दा फेरि यो तलतिरको पार्ट पर्यो। अब यसपछि यो लाइनले फेरि के भन्यो भन्दा यहाँदेखि यता मात्रै भन्दियो। त्यसकारणले यो लाइन हेर्नुस् त, यो लाइन यो सबै यिनीहरु चाहिँ यो 4 वटै लाइनको सोलुसन सेट हो। यी सबैलाई मान्य हुने अवस्था हो, सेटिस्फाइड एरिया हो यो। त्यसकारणले यसलाई हामी O, सपोज यो O भनौं। अब हामी 0 0 हो यो O। त्यस्तै यसलाई हामी A भन्न सक्छौं। A चाहिँ हेर्नुस् त 5 10 15 20 20,0 छ यो। त्यस्तै फेरि यो पोइन्ट कति होला त हामी यहाँ हेर्न सक्छौं। यो पोइन्ट OA, यसलाई हामी B भनौं। त्यस्तै एकछिन हामी यसको फाइन्ड आउट गरौँला। अब यसलाई हामी C भनौं, OABC। यो C पोइन्ट चाहिँ कति होला त हेर्नुस् त। C पोइन्ट भनेको 5 10 15 20 25। भनेपछि x चाहिँ कति छ? 0 छ, y चाहिँ 25 छ। यसरी यो B पोइन्ट हेर्नुस् त, यहाँ 5 10 हामीले सिधा 10 बाट यहाँ पुग्यौं, अनि यो के रहेछ त भन्दा 10 अनि 20 रहेछ। अब यसरी यसको चाहिँ कतिवटा कर्नर, यसलाई हामी कर्नर्सहरु भन्छौं। These 4 are the corners. So the corners, 4 corners are, हामीले यसलाई यसरी लेख्न सक्छौं, the plane region satisfying all the given condition is OABC. गिवन कन्डिसन सेटिस्फाई गर्ने के रहेछ त? OABC छ। The corner points or vertices भन्छौं यसलाई, are O 0 0 A। हेर्नुस् त कति छ? A हाम्रो 0 and then A 20 0 and then B we have 10 20 and C 0 25। यसरी हामीले चाहिँ यो कर्नर्सहरु फाइन्ड आउट गर्यौं। जुन हाम्रो क्वेशनले के भनेको थियो हेर्नुस् त, फाइन्ड द कर्नर पोइन्ट्स भनेको थियो। कर्नर्सहरु यिनीहरु हुन्। अब हामी यो भन्दा अझै कम्प्लिकेटेड टाइपको क्वेशन, जुन कर्नर फाइन्ड आउट गरिसकेपछि हामीले त्यसको म्याक्सिमम भ्यालु र मिनिमम भ्यालु कसरी फाइन्ड आउट गर्ने भन्ने प्रकारको अर्को क्वेशन हामी हेर्न जाँदै छौं। Students, now we are going to start another one question of our linear programming. Our question number 3 is, find the maximum and minimum values of objective function x plus 40y subject to the constraints y minus x is less or equals to 3, y minus x is greater or equals to 1, 2 is less or equals to x is less or equals to 5. Now, how to solve this question? Let us start from the solution. The corresponding, first we have to write the corresponding equations of the given inequality. inequalities are first y minus x is less or equals to 3 लाई हामीले y minus x is equals to 3 लेख्छौं. This is equation 1. Again, y minus x is equals to greater or equals to 1 like is equals to 1. This is equation 2. Again, we have another one is 2 is less or equals to x means 2 is equals to x, or that means we can write x is equals to 2. This is equation 3. And then next one is x is less or equals to 5 means x is equal to 5. This is equation 4. Now from equation 1, from equation 1, हामी equation 1 हाम्रो के छ भन्दा y minus x is equals to 3 छ. यसलाई हामी यसरी एउटा टेबल बनाउँछौं. टेबलमा हामीले के राख्छौं भन्दा x र y. अब x को भ्यालु हामीले यहाँ हेरौं त x को भ्यालु यदि हामीले 0 राख्यौं भने, यदि x को भ्यालु हामीले 0 राख्यौं भने y को भ्यालु कति हुन्छ त हेर्नुस् त, y is equal to 3 हुन्छ. यहाँ 0 भयो, y minus 0 is equal to 3, y is equal to 3. त्यस्तै y को भ्यालु चाहिँ if we put it here 0, then 0 minus x is equal to 3. So minus x is equal to 3, x is equal to minus 3. So here are the 2 points 0, 3 and minus 3, 0. So let's plot this 0, 3 and minus 3, 0 in a graph paper. Here हामीले 0, 3 points 0, 3 and minus 3, 0 are plotting on a graph paper. पोइन्टहरु हामीले प्लट गर्नको लागि हामीले ग्राफको हेल्प लिएका छौं. x यो हाम्रो x dash, त्यस्तै फेरि यो y भनौं हामी y, and then this one is y dash. This one is 0, 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, यस्तै minus 7, minus 8 राख्न सक्छौं हामी. Similarly 1, 2, 3, 4, 5 यो पोइन्ट होइन, 6 and then 7, 8 यसरी हामी राख्न सक्छौं. Similarly minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, or like this one minus 8. Now let us plot this point 0, 3 and minus 3, 0. 0, 3. 0, 3 is this point, and then minus 3, 0 is this point. So let us join these 2 points. विद्यार्थी भाइ बहिनीहरु हेर्नुस् है त, हामीले यो पोइन्टलाई यसरी जोइन गरिराखेका छौं. यसलाई लेट्स प्रोड्युस दिस लाइन. And the name of this line is, we have y minus x is equal to 3. Y minus x is equals to 3. Now let us take a testing point. Testing point 0, 0, because this line also doesn't passes from origin. So we can take testing point 0, 0. So we have y minus x is equal to 0 minus 0 is equal to 0, and then our equation is less or equals to 3, and 0 is smaller than 3, so which is, we can write which is true. So if this one is true, it represents towards origin. यसरी यसले चाहिँ origin तिर रिप्रेजेन्ट गर्छ. यो इक्वेसन हाम्रो हेर्नुस् त, इनइक्वालिटी y minus x is less or equals to 3 हो. यो y minus x equals to 3 ले यो लाइन भन्दा यतातिरको पार्टलाई चाहिँ रिप्रेजेन्ट गर्छ. Is the closed half plane containing the origin. यसले ओरिजिन तिरको पार्टलाई चाहिँ रिप्रेजेन्ट गर्छ भन्यौ हामी. On the same way, we are going to take from equation 2. Equation 2 is y minus x is equals to 1. Y minus x is equals to, instead of 3, we have to write 1. Now our process is same. If we'll put x, then y is equals to 1. And then if we'll put here y 0, then x is equals to minus 1. So let us points 0 1 and minus 1 0 are plotting on the graph paper. This is 0 1, 0 1 and minus 1 0. 0 1 is this point and minus 1 0 is this point. So let us join these 2 points and we have to produce the line. We are going to join these 2 points. Let us produce these 2 points. The name of this line is y minus x. Y minus x is equals to 1. This is the name of this line. Now we have to take again testing point. We have to take like this testing point. अब यसको लागि चाहिँ हामीले taking testing point. Taking testing point 0 0. Why we are taking always testing point 0 0, students? Because this line, if this line doesn't passes from origin, and it's easy to take testing point. If this line passes from origin, at that time we have to take another one testing point. यो टेस्टिङ पोइन्ट लिँदाखेरि चाहिँ यो लाइनमा नपर्ने पोइन्ट मात्रै टेस्टिङ पोइन्ट लिनुपर्ने हुन्छ. जुन लाइनमा हामी टेस्टिङ पोइन्ट गर्दैछौँ त्यो लाइनमा नपर्ने पोइन्ट मात्रै हामी टेस्टिङ पोइन्टको रूपमा लिनुपर्ने हुन्छ. अब हामी यसमा चाहिँ 0 0 हाम्रो त्यो लाइनमा नपरेको कारणले गर्दाखेरि टेस्टिङ पोइन्ट 0 0 लिँदैछौँ. हेरौँ है त, हाम्रो क्वेसन हाम्रो y minus x छ. Y minus x is equals to instead of y we have to write 0 and then instead of x also 0. So 0 minus 0 is also 0, and then our condition is greater or equals to 1. Greater or equals to 1. So we can write like this one. 0 is greater than 1. 1 भन्दा 0 चाहिँ के छ? Greater छ. Is it true or not? So we have to write which is not true. Not true or false. Or we can write which is false. So if not true, then the solution set of y minus x greater or equals to 1 is the closed half plane containing opposite or away from origin or away from origin. So यो यसले चाहिँ के रिप्रेजेन्ट गर्छ भने ओरिजिन भनेको यता तलतिर पर्यो, यसलाई रिप्रेजेन्ट गरेन, यसलाई यसरी रिप्रेजेन्ट गर्यो. यो माथितिरको पार्टलाई यसले चाहिँ यसरी रिप्रेजेन्ट गर्दो रहेछ. We can show like this one, and the name of this inequality is y minus x. Y minus x is greater or equals to 1. Now again we have another one equation. Equation 3. So x is equal to 2. So where is the line which represents x is equal to 2? So here is x is equal to 2. We can draw one line passes from. So this is the line which x is equal represents x is equal to 2. Our question is 2 is less than x or x is greater than 2. x चाहिँ 2 भन्दा ग्रेटर छ भनेपछि यो यसरी रिप्रेजेन्ट गर्छ यो पार्टलाई. यस्तै यसले पनि हेर्नुस् त यो पार्टलाई यसरी रिप्रेजेन्ट गर्छ. And then this part we can represent 2 is less or equals to x. It represents this area. Again we have x is x is equal to 5. यसरी हामीले इक्वेसन 3 लाई डाइरेक्ट हामीले राख्यौं. Similarly, we can write this equation for also direct. X is equal to 5. So x is equal to 5 is this line, this point. So the line which passes from this point is x is equal to 5. अब हेरौँ है त हामी. So x is smaller than 5. x 5 भन्दा के छ स्मलर छ. यो लाइनको नेम के हो भन्दा x is equals to 5 is the name of this line. And then our question is x is smaller than 5 means x is smaller than 5 or equals to 5, which represents in this side area. Because x is smaller, x चाहिँ 5 भन्दा सानो छ भनेपछि सानो स्मलर हुनलाई यो 5 भन्दा यता आउनु पर्यो. 4 3 2 स्मल हुँदै आउनु पर्यो. त्यस्तै यो चाहिँ x चाहिँ 2 भन्दा ग्रेटर हुनलाई यता बढ्दै गएको नम्बर छ. ग्रेटर हुनलाई उता जानु पर्यो, स्मलर हुनलाई यता आउनु पर्यो. त्यसकारणले अब अहिले हामीले 4 वटै इक्वेसनले रिप्रेजेन्ट गरेको एरिया कुन हो त? नाउ द इम्पोर्टेन्ट फोकस पोइन्ट इज हियर. यो लाइनले यो भन्दा तलको पार्टलाई रिप्रेजेन्ट गर्छ भन्यो यो इक्वेसनले यो भन्दा माथिको पार्टलाई रिप्रेजेन्ट गर्छ भन्यो. यो लाइन भन्दा यताको पार्टलाई रिप्रेजेन्ट गर्छ भन्यो यसले. फेरि यसले चाहिँ यो भन्दा यताको पार्टलाई रिप्रेजेन्ट गर्छ भन्यो. त्यसो भने यो सबैले चाहिँ हेर्नुस् त सेटिस्फाई गर्ने एरिया यो हुन आउँछ जुन अहिले मैले स्याडो गरिराखेको छु. दिस इज द सोलुसन सेट अफ दिस क्वेसन. In this way, this is the solution set. So we have to find the vertices of this solution set. Okay, let's look here. 2 and then 2 3. Suppose this is A, we can write 2 3. And then this one is suppose B. So B is 5 and then let's look here. 5 8. This represents 5 and 6. And then this one is C. So it represents 5 and then 8. 5 8. You कसरी भन्दा this one is 5 and then this one is 8. This one is 5 and this one is 6. So 5 6 5 8 and this one is 2 and this one is 3. And then A B C and then we have to write this one is D. So D is, so this one is 2 and this one is 5. So 2 5. Therefore the four corners are A to 3, comma B 5 6, comma C 5 8, this one 5 8 and then D and D to 5. These are the four corners for maximum and minimum. Let us draw one table. The objective function is the objective function is 9x plus 40y. So let us draw a table where we'll write here corners or vertices. अब हेरौँ है त हामी यसमा. Our corners are A to 3, B 5 6, C 5 8 and D to 5. Objective function. Our objective function is 9x plus 40y. So let's put the value. 9 times 2, x means 2. 9 times 2 plus 40 times 3 is equals to 138. Similarly, we have another one. 9 times x means 5 plus 40 times 6 is equal to 285. And the next one is 9 times x is 5 plus 40 times y is 8. This is equals to 365. And the last one is 9 times x is 2 and y is 5. 40 times 5 is equal to 218. So here, which one is maximum? So here 365 is maximum, and then 138 is minimum. Therefore minimum value, therefore we have to find, according to our question, we have to find the maximum and minimum values. So maximum value is, therefore the maximum, therefore the maximum value is 365 at which point? 58. At 58. And the minimum value is, the minimum value is 138 at the point 3. In this way, we found the maximum and minimum value of this given question. This is the complete answer of this question. Students, now we are going to start another one question, that is question number 4. At first, we study question number 1, which is very easy and short question, and we shadow the two inequalities in question number 1, and in question number 2 we found the corners, and then on question number 3 we found the maximum and minimum values. Now question number 4 is like a verbal problem. So this inequalities has such type of question. Okay, look very carefully. A shopkeeper wishes to buy some pens and copies. Pens cost Rs 18 each and copies cost Rs 12 each. The shopkeeper has no place for more than 20 pens and copies and cannot afford to pay more than Rs 288. If he can reasonably expect to make a profit of Rs 11 per pen and Rs 9 per copy, how many of each should he buy in order to make his total profit as large as possible? How can we connect this question to the linear inequalities? Okay, here according to this question, let's start the solution. Suppose he needs to buy X pens and Y copies respectively. His profit is the objective function Students, I think you know very well x pens and y copies when we suppose, and then objective function is his profit. So this is the link profit to the objective function. Here 11 pen and 9 copy here. So 11x plus, you can write 11x plus 9y is the objective function. The given constraints, now the given constraints are what are the given constraints? Here we use this 11 and then this 9 only up to now. We have at first here x plus y. X plus y is less or equals to 20 because here is 20 pens and copies. He has no place for more than 20 pens and copies भनेको छ। त्यस कारणले उसँग टोटल पेन र कपिज गरेर कति छ त टोटल उसँग लिन मिल्ने प्लेस कति छ भन्दा 20 भन्दा बढी छैन। त्यस कारणले x plus y is less or equals to 20 हामीले लेख्यौं। Similarly we have 18x plus, here pen cost rs 18, so pen is x, so rs 18 of each pen, so 18x is the total cost of the pen, and then copies cost rs 12 each, so 12y is less or equals to and cannot afford to pay more than rs 288. So total money he have is rs 288. So he cannot buy more than this rupees. So maximum amount is this one. So this is the another one inequality. Now we can take common here, or we can write or. Here 6 is common, so 3x plus 2y is less or equals to 288, or we can write again 3x plus 2y is less or equals to this, divide 288 divided by 6, it comes 48. This is another one. And we have x is greater or equals to 0, and then y is also greater or equals to 0 because pen is greater than 0, and then that copy is also greater or equals to 0. Students, now this question is converted on this linear inequalities form. यसरी हामीले यस्तो प्रकारको क्वेशनलाई चाहिँ लिनियर इनइक्वालिटी सँग कसरी कम्पेयर गरेर यो क्वेशनलाई हामी लिनियर इनइक्वालिटी सँग कम्पेयर गरेर कसरी लिनियर प्रोग्रामिङबाट हामी प्रब्लम सल्भ गर्छौं भन्ने कुरा बुझ्नको लागि यो एक्जाम्पल 4 अथवा क्वेशन नम्बर 4 तपाईहरु सामु आइरहेको छ। अब हामीले चाहिँ हेर्नुस् त यो कन्डिसनलाई युज गरेर हामी यसको सोलुसन फाइन्ड आउट गर्दै छौं, अथवा यसको चाहिँ म्याक्सिमम प्रॉफिट हेर्नुस् त प्रॉफिट एज लार्ज एज पोसिबल भनेको छ, यो हामी फाइन्ड आउट गर्न जाँदै छौं। वी क्यान राइट x plus y is equals to 20, x plus y is equals to 20, equation 1. Similarly 18x plus 12y, 18x plus 12y is equals to 288, equation 2. And then x is equal to, students, instead of this we can write 3x plus 2y is equal to 48. We can write, or we can write, this one is more easy, 3x plus 2y is equals to 48. We can say this is equation 2. And then equation 3 is x is equals to 0, equation 3. And then y is equal to 0, equation 4. Now let's take from equation 1. So from equation 1, first equation हाम्रो x plus y is equals to 20 छ। अब यसलाई हामी एउटा टेबलमा हेरौँ है त। x similarly y. So if we'll put the value of x is 0, then y is equal to 20. हेर्नुस् त, y 0 भयो भने x 0 भयो भने 0 plus y is equal to 20. So y is equal to also 20. If you will put y 0, then x is equal to 20. So our points are points 0, 20 and 20, 0 are plotting on a graph paper. Let's plot these points on a graph paper. Students, here this is a graph and this one is x-axis and this one x-axis dash. So this one is y and then y dash y-axis, and this one is origin O. So here 10 small division is equal to 1 unit. We are taking 10 small division is equal to 1 unit. So at first we have to plot the point 0, 20. So this one is x 0 and then y 20, means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This one is, this is 0, 20. Similarly, x 20 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then y is 0. Let's join these 2 points. So this one is 3x. We have x plus y is equals to 20. So let's take testing point. Taking testing point 0, 0. That one is x plus y is equals to 0 plus 0 is equals to 0, and we have here 20 and which is less or equals to, so 0 is less or equals to 20. It's, this one is true, so we can write which is true. So if this one is true, so we can write the solution set. Therefore the solution set of x plus y less or equals to 20 is the closed half plane containing the origin. Containing the origin. So we have to give arrow like this. यो origin तिरै हामीले यसरी चाहिँ यसको चाहिँ arrow दिन्छौं अथवा shadow गर्छौं. यो arrow लाई चाहिँ हामीले केले रिप्रेजेन्ट गर्छौं अथवा यो लाइन भन्दा यताको एरियालाई हामीले चाहिँ x plus y is less or equals to 20 भनेर यसले चाहिँ रिप्रेजेन्ट गर्छौं. यो इनइक्वालिटीले रिप्रेजेन्ट गर्छौं. यसरी यो लाइन भन्दा यो तलको एरियालाई चाहिँ यो इनइक्वालिटी हाम्रो क्वेशनले दिएको यो इनइक्वालिटीले रिप्रेजेन्ट गर्छ. त्यस्तै from equation second again from equation second के छ हाम्रो भन्दाखेरि 3x plus 2y is equals to 3x plus 2y is equals to हाम्रो यहाँ 48 छ. 3x plus 2y is equal to 48. So let us draw a table which contain x and y. So if we'll put x is equal to 0, then y is equal to 24. So if we'll put y is equal to 0, then 2 times 0 is 0, 3x is equal to 48, and x is equal to 16. And if we'll put x is equal to, suppose, y is equal to 10, or we can put y is equal to x is equal to, direct we can write 0, then x is equal to 0, then 3 times 0 is 0, so 2y is equal to 48, y is equal to 24. So points, therefore points 16, 0, 16, 0 and 0, 24 lies on the boundary line of equation second, or plotting on a graph paper. यसलाई चाहिँ हामी ग्राफ पेपरमा अब प्लट गरौँ. 16 0 16 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 हामीले यसमा पोइन्ट नम्बरहरु लेख्यौं भने इट्स इजी हुन्छ. त्यस्तै 0 24 0 and then this one is 20, this is 21, 22, 23 and this one is 24. 0 24. So let us join these 2 points. यो लाइन को नेम हो हाम्रो 3x plus 2y is equal to 48, or we can write 18x plus 12y. Can write 18x plus 12y is equals to 288. अब हामी यसको लागि पनि टेस्टिङ पोइन्ट लिनु. टेकिङ टेस्टिङ पोइन्ट, टेकिङ टेस्टिङ पोइन्ट 0 0. यो 0 0 मा नपरेको भएर हामीले टेस्टिङ पोइन्ट 0 0 लिन सकिने अवस्था भयो. So 3x plus 2y is equals to 3 times x means 0 plus 2 times y means also 0. So 0 plus 0 is equals to also 0. So here is 48. So we can write here is also 48 and then here is less or equals to 48. जे छ हाम्रो क्वेशनमा हामीले त्यही इनइक्वालिटीलाई ल्याएर राख्छौं. अब हेर्नुस् त 0 48 भन्दा स्मलर हो, त्यसकारणले which is true. यो ट्रू हुने बित्तिकै हामीले चाहिँ के भन्न सकियो त, therefore the solution set of 3x plus 2y lesser equals to 48 is the closed half plane containing the origin. यसरी यसले चाहिँ ओरिजिन तिरै रिप्रेजेन्ट गर्ने भयो. त्यसकारणले यसलाई पनि हामीले के गर्न सकिने भयौं त, हेर्नुस् त, यसलाई हामीले यस्तो गरेर यसलाई पनि यतै हामीले चाहिँ एरो दिनु पर्ने भयो. यही एरियालाई चाहिँ रिप्रेजेन्ट गर्ने भयो. केले त भन्दा 3x plus 2y lesser equals to 48 ले 3x plus 2y lesser equals to 48. यसलाई हामीले चाहिँ 18x plus 12y is lesser equals to 288 लेख्न पनि सक्छौं. Dear students, we completed equation 1 and equation 2. Now we have to solve equation 3. Our equation 3 is x is greater or equals to 0. So here this is the line which contain x is equal to 0. Y-axis is the line where x is equal to 0. So x is greater or equals to 0 represents this area. x इज ग्रेटर अर इक्वल्स टु 0 x 0 भन्दा ग्रेटर छ भनेर यो यता बढ्दै जाँदाखेरि x को भ्यालु ग्रेटर छ स्टुडेन्ट्स तपाईहरुले यो यसमा चाहिँ नम्बरहरु 1 2 3 4 यी नम्बरहरु तपाईहरुले लेख्न सक्नुहुन्छ यसरी यो एरियालाई चाहिँ x ग्रेटर अर इक्वल्स टु 0 ले रिप्रेजेन्ट गर्छ त्यस्तै यो लाइन भनेको हाम्रो इक्वेसन अर्को इक्वेसन 4 मा हाम्रो के छ y इज ग्रेटर अर इक्वल्स टु 0 छ यो x भनेको हाम्रो y इज इक्वल टु 0 को लाइन हो x एक्सिस भनेको y इज इक्वल टु 0 को लाइन हो अब y इज ग्रेटर अर इक्वल्स टु 0 भयो y ठुलो हुनलाई माथि आउनु पर्छ त्यसकारण यसले चाहिँ के रिप्रेजेन्ट गर्छ y ग्रेटर अर इक्वल्स टु 0 को भ्यालु यसले रिप्रेजेन्ट गर्छ यो एरियालाई त्यसकारण हामीले यसलाई पनि यसरी रिप्रेजेन्ट गर्छौं यसरी हामीले इक्वेसन 1 इक्वेसन 2 इक्वेसन 3 इक्वेसन 4 सबैलाई हामीले ग्राफ पेपरमा प्लट गर्यौं अब यसको चाहिँ हामीले सोलुसन सेट हामीले फाइन्ड आउट गर्नु छ यी सबै इक्वेसन 4 इक्वेसनहरुले नै रिप्रेजेन्ट गर्ने सोलुसन सेट के हो त 4 इक्वेसनलाई नै सेटिस्फाई हुने सोलुसन सेट कर्नर्सहरु के हो र त्यसको म्याक्सिमम मिनिमम भ्यालुहरु के हुन्छन् अब एकछिन हामी हेरौं हेर्नुस् त हाम्रो सबै 4 वटै इक्वेसनले सेटिस्फाई गर्ने एरिया भनेको हाम्रो यो एरिया हुन आउँछ यो एरिया चाहिँ हेर्नुस् त यो सबैतिरबाट यो सेटिस्फाई भएको एरिया हो किनकि तपाईहरुलाई लाग्छ कसरी यो भन्ने क्वेशन आउन सक्छ हेर्नुस् है त यो इक्वेसनले चाहिँ x यहाँ भन्दा यता छ ग्रेटर छ भनौं यसले y यहाँ भन्दा माथि मात्रै छ भने यो भन्दा तल छैन यो भन्दा यता पनि छैन त्यस्तै यो हाम्रो यो ब्लू लाइनले यो भन्दा यता छ यो x + y लेसर इक्वल्स टु 20 भनेको छ यो साइडमा फेरि यो रेड लाइनले हेर्नुस् त यो भन्दा यता मात्रै भनेको छ त्यसकारणले यहाँ एउटा पोइन्ट इनीहरुको बीचमा आयो त्यस्तै अब हामीसँग यो o यो 0 0 भन्ने छ ओरिजिन हो यो त्यस्तै यो पोइन्ट कति होला त हेर्नुस् त यो पोइन्ट हाम्रो 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 यसलाई हामी a भनौं दिस इज 16, 0 and then this one is b यो पोइन्ट कति होला त हामी हेर्न सक्छौं यो पोइन्ट भनेको 1 2 3 4 5 6 7 8 हुन्छ है 1 2 3 4 5 6 7 8 and then here हेर्नुस् त 1 2 3 4 5 6 7 8 9 10 11 12 8 12 हो यो पोइन्ट भनेको हामीले यहाँ हेर्न सक्छौं 8 अनि 12 त्यस्तै यो पोइन्ट यसलाई हामी c भनौं यो पोइन्ट भनेको कति छ हेर्नुस् त हामीले 0 अनि त्यसपछि 20 लाई यो पोइन्ट राखेका छौं अब यसको 4 कर्नर्सहरु के आए त therefore the 4 corners are O 0 0 A 16 0 OA B 8 12 and C 0 20 यसरी 4 कर्नर्सहरु हामीले फाइन्ड आउट गर्यौं अब यसको हामी म्याक्सिमम र मिनिमम भ्यालु फाइन्ड आउट गर्दै छौं for maximum भ्यालु हामी म्याक्सिमम भ्यालु मात्रै फाइन्ड आउट गर्न छौं हामीले किन भन्दा प्रॉफिट एज लार्ज एज पोसिबल भनेको छ for maximum value our objective function 11x + 9y छ त्यसकारणले अब हामी लेखौं कर्नर्स objective function अब हेरौं है त हाम्रो कर्नर्स O that is 0 0 A that one is 16 0 and then B 8 and 12 C 0 and 20 Our objective function is 11x plus 9y. 11x plus 9y भनौँ हाम्रो objective function. So 11 times x is 0 plus 9 times 0. 0 0 हामीले राख्दाखेरि 11 times 0 plus 9 times 0 is equals to 0. So here is 16 times 16 and 0. So we can write 11 times 16 plus 9 times 0 is equals to 176. Similarly, we have 11 times 8 plus 9 times 12 is equals to 196. And then 0 20 is 11 times 0 plus 9 times 20 is equal to 180. So which one is maximum? 0, 176, 196 and 180, and this one is maximum. The maximum, therefore, the maximum value occurs at the point 8, 12. At the point 8, 12, hence the shopkeeper can buy 8 and 12, 8 pens and 12 copies. Shopkeeper should buy 8 pens and 12 copies. In this way, we found the answer of this question. यसरी उले चाहिँ म्याक्सिमम प्रॉफिट गर्नको लागि हेर्नुस् त कति किन्न पर्ने रहेछ भन्दा 8 पेन र 12 कपीज किन्न पर्ने रहेछ. यो क्वेशनको भने आन्सर हाउ मेनी अफ इच शुड ही buy in order to make his total profit as large as possible भनेको थियो. यसकारणले उसले चाहिँ सकेसम्म धेरै प्रॉफिट गर्नको लागि के देखायो त यसले भन्दा 8 पेन्स र 12 यसले चाहिँ कपीज किन्नु पर्ने रहेछ. विद्यार्थी भाइ बहिनीहरु, पक्कै तपाईहरुलाई यो क्वेशन देखेर रमाइलो लाग्यो होला. यो क्वेशनलाई हामीले चाहिँ कसरी हेर्नुस् त लिनियर इनइक्वालिटी सँग कम्पेयर गरेर यसको चाहिँ प्रॉफिट म्याक्सिमाइज गर्ने कुरा रहेछ भन्ने कुरा हामीले यसबाट थाहा पायौं. र पक्कै तपाईहरुलाई अब यो लिनियर प्रोग्रामिङको यस्तो खाली प्रब्लमसँग अब कन्फ्युजन नहोला. I hope you are clear about this one. Students, now we are going to start simplex method of this linear programming, and this is the first question of this linear programming. Using simplex method, maximize z is equal to 7x1 plus 5x2 subject to x1 plus 2x2 is less or equals to 6, 4x1 plus 3x2 is less or equals to 12, and x1 comma x2 is greater or equals to 0. Now, how to solve this question? Okay, don't go anywhere. Stay and look here. Solution. Let x3 and x4, because here is x1 and x2, so we let it x3 and x4 are the non-negative slack variables. Adding the slack variables, we can write the given linear programming problem in the following form. We have here x1 plus 2x2. So x1 plus 2x2 plus x3 is equals to 6. Similarly, 4x1 plus 3x2 plus x4 is equals to 12. And z is equal to 7x1 plus 5x2, which is on here. Z is equal to 7x1 plus 5x2. In this way, we wrote this one and then this one and this one also here, and which gives x1 plus 2x2 plus x3 plus 0 times x4, because there is no x4, so 0 times x4 is also 0, plus again 0 times z is equals to 6. So here is no z also, so 0 times z. यसरी हामीले 0 times z लेखे नि 0 हुन्छ, 0 times x4 लेखे पनि 0 नै हुन्छ। त्यसकारणले x1 plus 2x2 plus x3 is equals to 6 नै भयो यो राख्दाखेरि पनि। तर हामीले यसलाई चाहिँ यसरी सेटअप गर्छौं। यस्तै गरी यसलाई हेरौं है त हामी। सो 4x1 plus 3x2 plus here is no x3, z छैन, त्यसपछि हामी 0 times राखिहाल्छौं, 0 times x3 plus here is x4, so we can write x4 and then no z here, so 0 times z is equals to 12. So similarly on here, if we'll bring this 7x1 on this left hand side, so here is minus, so minus 7x1 minus 5x2 plus 0 times x3 plus 0 times x4, because there is no x3 and x4, so we wrote it 0, and then here is 1 z plus z is equals to, if we'll bring this all in the left hand side, then minus 7x1 minus 5x2 plus z is equal to 0. So we'll write here is equal to 0. Now we are going on step second, that is construction of simplex tabulae, x3 and then x4. So here is x3, means we have, here we have to write this x1 1. So 2x2 is, x2 is 2, coefficient like this, x3 is 1, then x4 is 0, and then z is also 0. So coefficient of x1 is 4. Similarly 3x2 is here, so here is 3, and then here is 0, and then here is 1, and then here is 0. Again the last one is here minus 7. So हामीले यसलाई चाहिँ यसरी line draw गरिसक्छौं, is equals to 6 and 12, so it's equal to here 6 and then here is 12. Now here minus 7, so here is minus 7, and then here is minus 5, and then here 0, and then here is also 0, and then z, it means 1 is here, and then here is also 0. Now we have to find which one is the most negative entry. Here is on the last row, minus 7 is the most negative entry. So let's write here minus 7 is the most negative entry in the last row. In the last row, यो लास्ट रो को हेर्नुस् त minus 7 चाहिँ के हो त, एकदमै सबभन्दा लोएस्ट इन्ट्री हो नेगेटिभ. सो the first column is the pivot column, first column. त्यस कारणले यो फर्स्ट हेर्नुस् त, यो फर्स्ट कोलम चाहिँ पिभोट कोलम भयो, यसको चाहिँ यो लास्टको फर्स्ट कोलम चाहिँ पिभोट कोलम भयो। अब यो पिभोट कोलम भइसकेपछि हामीले यसको चाहिँ रेशियो निकाल्न पर्ने हुन्छ 6/1 त्यस्तै 12/4। नाउ वी आर गोइङ टु फाइन्ड the ratio. Since here is 6/1, we have to do 6/1 is equals to 6. Next one is your 12/1. We have to find the ratio of these. 12/4 is equals to 3. And then 6 and 3, which one is the smallest? We can write, and 3 is less than 6. So 4 is the pivot element. यो हाम्रो के भयो भन्दा यो 12/4 भन्दाखेरि स्मल आयो, त्यसकारणले 3 स्मल भयो। जुन स्मल छ त्यसको यो 4 चाहिँ हेर्नुस् त, यही ट्याक्क यही रोको यो 4 चाहिँ पिभोट एलिमेन्ट भयो हाम्रो। अब हामी यो पिभोट एलिमेन्टलाई हामी के बनाउनु छ अब हेर्नुस् है। नाउ एप्लाइङ हामीले चाहिँ हेर्नुस् त यो R2 लाई एप्लाई गर्दैछौँ। R2 टेन्स टु, यसलाई 1 के गरेर हामीले 1 बनाउन सकिन्छ होला त, R2/4 गर्यौँ भने here is 4, so 4/4 हुन्छ। एन्ड देन यसलाई हामीले चाहिँ पिभोट एलिमेन्टलाई हामीले 1 बनाउनु जरुरी छ, त्यसकारणले 1 बनाउनको लागि हामीले R2/4 गर्नु पर्ने हुन्छ। अब बेसिक variables, and then here is x1, x2, x3, x4, and then z, RHS बीमा x3, this one is, and then x1 here. So here our x3 is 1, 2, 1, 0, 0, and this one is 6. So x1 is here 4. Here is R2, हेर्नुस् त, R2 लाई 4 ले डिवाइड गर्दाखेरि R2 means 4, 4/4 is 1. Similarly, this 3 divided by 4 means 3/4. This is 0 divided by 4 is also 0. And this one is 1 divided by 4 is 1/4. And this 0 divided by 4 is 0. This is 12 divided by 4 is 3. And the last one is here same. So -7. And then -5, 0, 0, 1, and then 0. Students, now we are going to change R1 because we have to make R1 to 0. So this minus this is 0. So now here applying R1 tends to R1 minus R2. Row first minus row second, first row minus second row. Similarly, we can change R3 also tends to R3 plus 7R2. हेर्नुस् त, R3 लाई हामीले कसरी चेन्ज गर्दैछौँ, R3 plus 7R2. 7 ले यो 1 लाई मल्टिप्लाई गर्दाखेरि 7 हुन्छ, 7 plus 7 it will be also 0. त्यसकारण हामीले यसलाई हेर्नुस् त के 0 बनाउँदै छौँ, यसलाई पनि हामी के बनाउँदै छौँ, 0 बनाउँदै छौँ। किन भन्दा हामीले 0 यो पिभोट एलिमेन्ट जुन छ त्यो बाहेक अरु सबैलाई चाहिँ यसमा 0 बनाउनु पर्ने हुन्छ। अब हेर्नुस् है त, आवर बेसिक भेरिएबल्स, बेसिक variables, and then here x1, x2, x3, x4, and then z, then RHS B right hand side को छ यो। अब यसपछि हामीले हेर्नुस् है त, अब यसलाई हामीले बिस्तारै सल्भ गरौँ। x3 and then x1 here. First we have to make it 0, so 1 minus 1, r1 minus r2 means this minus this is 0, 1 minus 1 is 0, and this minus this, 2 minus 3 by 4 means we look it here, 2 minus 3 by 4, 2 minus 3 by 4, it means for LCM 4 times 2 is 8, 8 minus 3, it means 5 by 4. So this one is 5 by 4. Similarly, here is 1 minus 0 is 1, and then 0 minus 1 by 4 is minus 1 by 4, and 0 minus 0 is also 0. 6 minus 3 is 3. Again here, the second one is same. Second one is here 1, and then this one is 3 by 4, and this one is 0 and 1 by 4. This one is also 0, and this one is 3. Drawing a line. Here minus 7. Here R3 changes into R3 plus 7R1, 7R2. So minus 7 plus 7 times 1 is plus 7. So this one is 0. So 0, 1, 0 is here. Again here, this one is minus 5. Minus 5 plus 7 times 3 by 4 means minus 5 plus 7 times 3 is 21 by 4. So by taking LCM for 20 minus 21 means minus 1 by 4. So we can write minus 1 by 4. Similarly, the next one is this minus 7 times of this is also 0 because 0 is here, and then this time this plus 7 times 1 by 4 is 7 by 4. Again this plus 7 times of this is 0 times 7 is 0, so here is 1. So this plus 7 times this is 21. 7 times 3 is 21. Students, now we look it. This is 0, 1 and 0. It's very easy question. Since all entries in the first row are non-negative, since all entries in the last row are non-negative, all entries in the last row are non-negative, so the solution is optimal. In this way we solve this question. यसरी यो optimal आइसकेपछि हामीले अब यसको चाहिँ आन्सर मात्रै लेख्नु बाँकी छ, maximum. So therefore maximum value of z is equal to maximum value of z, हेर्नुस् त यहाँ 21 आएको छ, that's 21 when x1 is equals to x1, हेर्नुस् त x1 is equal to हाम्रो कति छ 3 छ, x1 is equal to 3 and x2 is equal to यहाँ हेर्नुस् त x3 भएको कारणले x2 इक्वल्स टु 0 छ। यसरी हामीले चाहिँ यसको म्याक्सिमम भ्यालु अफ z फाइन्ड आउट गर्यौं र x1 3 र x2 0 पनि फाइन्ड आउट गर्यौं।